Alright, here's another problem. This one will require conversion of 2 units, and so we'll get practice with that aspect. Alright, it says an unknown substance, which the computer identifies as UNK, was poured into an empty graduated cylinder. Final volume of the substance was 43.2 milliliters, and by weighing the cylinder empty and again with the liquid in it, it was determined that the liquid had a mass of 56.8 grams. Determine its density, and here's the part that we need to pay attention to, in nanograms per femtoliter. Kind of strange units, but it'll give us practice of this unknown substance. Alright, so we're given its volume in milliliters and its mass in grams, and we want its density in nanograms per femtoliter. Okay, so density, of course, is mass divided by volume. So here's our mass, we divide that by the volume, and then we're going to convert these volume units, the milliliters, to these volume units, the femtoliters. And likewise with the mass, we'll convert the grams into nanograms. Alright, so let's go ahead and get started with this. You'll see here. So the first thing we need to do is say, all right, I'm working with a 2-unit problem because we're having to convert both the grams and the milliliters. All right, so you'll notice it says denominator, numerator. All right, so first we're going to work with the numerator, and the numerator is going to be what? Density is mass over volume. So first we're going to work with the mass part of it, and we started with grams. So just like before, we're going to click on the actual unit, and it highlights that, and then we need to convert that to nanograms. Right? So this one is actually pretty straightforward. Here's our nanograms, and just like before, all of these, if we were going the other way, they'd all stop at grams. Okay, and then we could branch off in any one of these other directions. Okay, so but since we're going this way, we're at the gram stop, and we just go straight over to nanograms, right? And we click on the box, not on the unit. We only click on the unit the first time. Okay, so that's the top part. We've gone from grams of our, it's saying substance A, but we'll set that in the next part, and grams to nanograms. Okay, so we're done with the numerator. Let's go to the denominator. Now, the denominator, mass over volume. So we're going to look at the volume table, and we're starting with milliliters. All right, so that's here, and you'll notice it highlights both of those because 1 cubic centimeter is 1 milliliter. They're the same size. And we were going to convert that to femtoliters. All right, so first, before we can go between either of those, we have to make our stop at liters. Then we can go up here to femtoliters. All right, and now if we look down below, we will see that conversion, and it has put it there for us in the denominator. Okay, and we've converted from milliliters to liters, and then liters to femtoliters. Okay, so here are our final units. We're done with this, so let's go to next. Alright, so now we have the opportunity to enter in our values. Alright, so it already put in our mass and our volume from the problem. And so again here we need to make sure we set all of these. I usually just do that first so that we don't forget about it later on. Okay. Oop. So once we have those all set, then let's go back and say, all right, 50, well, we're going from grams to nanograms. So we want to know how many nanograms are in a gram. Okay, so I'm going to do this one a little bit differently just for demonstration purposes. We know nano is 10 to the minus 9th, right? So a nanogram is 1 e to the minus 9th grams, right? So 1 nanogram is 1 times 10 to the minus 9th grams, or we could say there are 10 to the 9th nanograms in 1 gram. So you can use different, you can put it either on the top or the bottom. It's just the sign will be different. Alright, now we're looking down here. We're going from milliliters to liters. How many milliliters in a liter? 1,000. Right? For all of these problems, you don't have to write you don't have to write it in scientific notation with the exponent, the e to the plus whatever. You can write it out with all the zeros if you want to. It doesn't matter. Alright, and then here we have femtoliters to liters. How many femtoliters in a liter? Well, femto is 10 to the minus 15th, so that would be 1 times 10 to the 15th femtoliters in 1 liter. Okay, again, we can say 1 femtoliter is 10 to the minus 15th liters, or we can say there are 10 to the 15th femtoliters in 1 liter. Either way, it is equivalent. Okay, so now let's do our calculation.